Everybody's favorite time for fractions. First, we're just going to talk about fractions. Don't forget that the line in a fraction means divide. So a fraction is just a fancy little way of writing a math problem. We had three things, we cut it into four pieces. We know that 3 divided by 4 is also like represented visually as one whole cut into four pieces, and we're taking 3 of them, right? 3/4. Okay. A fraction can also be represented as a decimal. We know 3/4 is the same as 0.75, 3/4, 75 cents. So every fraction has a decimal value, and also every whole number could be represented as a fraction if you preferred to. You just put it over 1. So in a fraction, the numerator is the top of the fraction. In 2/5, 2 is my numerator, 5 is my denominator. And 2 is telling me how many pieces I have. 5 is telling me how big the pieces are, but you need to be careful because it's a little backwards. It's saying I took one whole and I cut it into 5 pieces. So the bigger a denominator is, the smaller those pieces are, right? If you cut something 10 times, you're getting much smaller pieces than if you cut it 3 times. So a bigger denominator gives you a smaller size piece. And then on the top, that numerator, how many pieces do you have? So a couple ways to look at these fractions. 3/5, you can write it, you can draw it in a circle. You can do these lovely bar graphs. You can write it as 3 divided by 5. You can write it as a decimal. You can even convert a decimal to a percent by timesing it by 100%, and that'll make it a percent. These are all just different ways to show the same things. 3/5 of a whole. 3 cut into 5 pieces. Okay, let's keep going. Every fraction has infinitely many ways it could be represented equivalently. So if we start with the fraction 2/3, I can make an equivalent fraction as long as I multiply the top and the bottom by the same number. I can multiply it by any number. Because when I multiply 2/3 by 5, as I did here to get 10/15ths, that 5 over 5 is really just a big 1. 5/5 is the same as 1. So I'm not changing the value of my fraction. I'm just changing the way it's represented. So I'm multiplying it by this invisible 1 by multiplying the top and the bottom by 5. Careful. You cannot add the same number to the top and bottom. You cannot subtract the same number from the top and bottom. That will not keep it the same value. All right, to go from 10/15ths to 60/90ths, I bet you know already. What did I do? I multiplied it by 6 on the top and the bottom. And then to get down here, there's a couple ways I could say it. I could say I multiplied it by 1/10, or we can just say I divided by 10 on the top and the bottom. We did the same thing, top and bottom. If you don't do the same thing, the value changes, okay? 6 to 24, I multiplied it by 4. 24 to 12, I divided it by 2. Every single one of these are all equivalent to 2/3. They're all just different ways of writing it. So you want to get really, really used to changing fractions to other equivalent fractions. It's going to make your life so much easier. Equivalent fractions have the same value, and you can take one and make it into the other, or you could change them both into a different one that had the same value. Equivalent fractions, same value. An improper fraction, you've seen them already, is one where the numerator is bigger than the denominator. As long as the numerator is bigger than the denominator, it's improper. You can also write it as a mixed number, not 1 2/3, but as a mixed number. Oop, there we go. A reduced fraction cannot be simplified any further. So if you think about prime factorization, we're going as small as we can get to where we can't simplify it any further. The same thing's happening with the reduced fraction. We're going to reduce one in just 1 minute. You're trying to divide out of the top and the bottom as much as you can until it can't go any farther. And then a mixed number has a whole number and a fraction. to be honest, when we get into algebra and linear equations, we're going to much prefer improper fractions. So I use improper fractions way more often than I use mixed numbers. But obviously we use mixed numbers in life a lot, like when you buy something that's $1.25. That's, well, that's a decimal, but 1 1/4 would be the mixed number. So to take an improper fraction and make it into a mixed number, what we're going to do is see how many times does 2 go into 5. And so you're just thinking about dividing. How many times does 2 go into 5? It goes in 2 times, because 2 times 2 is 4, but 2 times 3 would be 6, which is too big. So I can take out 2 groups of 2. That's my whole number. And then I see what I have left. To get from 4 to 5, there's 1 left. So this is the same as 2.5. Looking at 12/5. I say, how many times does 5 go into 12? 5 goes into 12 2 times. So I should have picked some different numbers, but it's fine. 5 times 2 is 10, which is as close to 12 as we can get without going over when we're doing multiples of 5. So we again have 2 groups of 5 to make my 10, and then left over I have 2 more fifths. So that's 2 and 2/5. We're going to go the other way in just a minute. Oh, look, it's now. From a mixed number to an improper fraction, we need to take this whole number and make it a fraction that has the same denominator. So 3 is going to change into halves. And we're saying, how many 1/2s are there in 3? 3 times 2, there are 6 of them. So that 3 changed into a 6/2. I still have that 1/2. Imagine there's a little tiny plus sign right here. And then I just add these guys together. 7/2. Some people do this in a faster, more abbreviated version. Of course you can do that. You can do it whichever way you learned it, but this is... So here we're going to take this a whole, turning it into fifths. There has to be 5/5 to make it a whole, right? So I have 5/5 plus those extra little 3/5 from the number. All together is going to make me 8/5. Okay, I did say we would get to reducing fractions. Here's how we're going to do it. Prime factorization is super helpful because one way to do this is to write out a way you can multiply to get to this number. So, like, I remember that 18 is 3 times 6. And I also remember that 42 is 6 times 7. And now, in a fraction, I have the same number on the top and the bottom. I have 6/6. You might remember that's that invisible 1. So these guys together cancel out to being just 1, and my fraction reduces to 3/7. Now, what happens if you don't remember your prime factorization? I mean, listen, that wasn't even prime factorization, right? Because 6 gets broken up smaller. But let's say you can't remember how to multiply to get these numbers. You don't have to. You're going to just start seeing what divides out, and whatever does work, you're going to take it out. And this one I noticed they're both even, so I'm going to divide by 2 on the top and the bottom. Don't forget. All right, so 18 divided by 2 is 9. 42 divided by 2 is 21. And now I again look and see, what could I divide out of both of these? Ooh, I know. I could divide a 3 out of both of these. And if you didn't know, listen, you would just start trying numbers in your calculator. It's fine. 9 divided by 3 is 3. 21 divided by 3 is 7. We end up at my same one. Now, how do I know this is as simple as it can go? One way I know is that 3 is prime. So there's no way that 3 is getting any smaller, right? Also, 7 is prime, so it's not getting any smaller either. However, you got to be careful, because let me think of a good one I could do. How about 10/21? Neither of these numbers are prime, but this is simplified as much as it can be, because if you think about the prime factorization, 10 is 2 times 5 and 21 is 3 times 7. So there's no one number that goes into both 10 and 21 that I could divide out. So 10/21 is as simple as it can go. So let's do some quick practices. If you want, pause right now and try these on your own. But I'm going to do them too. So I'm going to divide by 5 on the top and the bottom. 6/9. Ooh, I could keep going from 6/9. I'm going to divide by 3 on the top and the bottom. Get 2/3. Can't go any farther than that. This is a Trixie guide. Do you know how to multiply to get 34? I do. It's 2 times 17, which means I could take 17 out of both of these. And this is actually just 1/2. 9/27. I could divide out 3 on both of these, but I know that 9 goes into 27. So I'm going to divide out 9 on both of them. Divide by 9, and we're going to get 1/3. Ooh, 45/55. Let's divide by 5, because it certainly sounds like 5 goes into all of these. 45 divided by 5 is 9/11. That's not going to go any farther. How about this one? Ooh, 22/99. I know those are both multiples of 11. So let's take 11 out. 2/9. Okay. Those are our examples for simplifying and reducing fractions for equivalent fractions.